Okay, hey guys, this is 1-5 for calc. I've written the homework assignment up here at the top, and this is inverse functions. I'm just going to jump right in. So inverse functions, the notation that we use looks kind of like f to the negative 1 power, but we never read him as f to the negative 1 power. We just say the inverse of f, or f inverse is what we call him. And the way that an inverse works is like an inverse of a function undoes what the regular function does, okay? So like the domain or the x values of a regular function will become the domain of the inverse, or like the domain of the inverse, or no, excuse me. The domain of a function is the range of the inverse. The range of a function is the domain of the inverse. So they like swap places with each other, if you can kind of see these little arrows going on here, okay? So if that was confusing, let me show you kind of a picture of what this looks like, okay? So I'm going to draw you the picture of, let's say, y equals x squared, okay? So y equals x squared starts here at 0. It's a parabola. If we go over 1, that means we're going up 1, because 1 squared is 1. 2 squared is 4. So we would go up to 4, etc. And he would be the same on the other side. So like this and whatever. That's what the parabola will look like, okay? But if I take the inverse of that, the inverse of y equals x squared is really x equals plus and minus the square root of, no, wrong. Let's do this. Let's say y equals plus and minus the square root of x, or you can write that as x equals y squared. Those two are meaning exactly the same thing. That's what the inverse function is going to look like. You probably have seen maybe x equals y squared more often than this one. But they're both the same thing. X equals y squared is just a parabola, but it's on its side. So we're going to start here, and we would go over 1 up 1, but we would go over 4 up 2, and that's what he would look like. He would look like just a parabola, but on its side, and the same on the other way, okay? So what's happening here is that these values here, like this value over here was the value like negative 2 comma 4. We switch those two around and we do 4 negative 2, and that's this dot right here, okay? Like let's pick on this dot right here is 1 comma 1. We flip that around and we get 1 comma 1 again, and that's why this dot is shared by both of the parabolas, because when you flip it around, it's the same, okay? Now, the important thing is that this happens, all right? Whenever you have an inverse, your two graphs will always be reflected across this magical dotted line called y equals x, which is a linear function, okay? So that's the huge important thing about the graphs of inverse functions, is that they will be flipped over top of that diagonal line, okay? All right, and we'll see that down below here. So finding an inverse function. We don't want to have to graph each one every time, so we're going to start with f of x equals 4x, and there are 4 steps to this, and you probably will remember these 4 steps from algebra as soon as I write them down. Step 1 is you take f of x and you rename it to say y, and then step 2 is you switch your x and your y around, so y and x switch places with each other. A lot of people do these 2 steps at the same time, and that is totally fine. Step number 3 is you solve for y. And then step number 4, you rename y as f inverse of x, okay? So we're going to do part A. We're going to do those 4 steps on this function. So step number 1 is we call f of x y. So we really have y equals 4x, okay? Step number 2, I switch the x and the y around. So x is equal to 4y. I just switch places with those two guys. And then the step number 3 is I'm going to solve for y. I'm going to get this y by itself. So I'm going to divide by 4. So y is equal to, and I can write that as x over 4. I'm going to write it as 1/4 x, just to get him off to the side over here. And then that was solving for y, so y is now by itself. And then the last thing that I'm going to do is I'm going to rename that y as f inverse of x. And I also am going to flip him to the other side. So I'm like in a trade places with these guys. I'm going to flip them around, okay? So f inverse of x equals 1/4 x. That's what my inverse function looks like. Okay, now in the last section, in section 1.4, we talked about composition functions, okay? And composition functions was like sticking one function inside of the other, So in part B, we're going to be doing the compositions, but we're going to be plugging them into each other, and I'll show you kind of how this works, okay? So over here, we're going to be doing f inverse of x, f composed of f inverse of x. Here we're going to be doing f inverse composed of f of x. This is what we're going to do over here, okay? So this is what we've got going on, all right? And this one, we're going to be taking the inverse and we're plugging it into f. This is my original f. Originally, f was 4x, but in its place, I'm going to put 1/4 x, okay? And what you will notice is that if they are truly inverses of each other, it will reduce and like everything will end up canceling out except for x, okay? So they will, when you compose one inside of the other, they will cancel out to be x. If we do the other direction, same thing. F inverse is my outside function. We're plugging f into that. So f inverse was 1/4 x, and we're plugging 4x inside of that. And we notice that the 1/4 and the 4 cancel out, so it ends up being equal to x, okay? Now, it's not that these two will end up being the same thing, the same number, the same thing. It will always end up reducing to x. These two have to be x no matter what in order for them to be inverses of each other. And the reason why it's x is because they're reflected across the line. Y equals x. Y equals x, okay? So when you compose them inside of each other, you know that they are inverses if they reduce to be x, okay? So that's kind of a way of checking yourself to see whether you did the inverse correctly or not. Or you'll get some on your homework assignment that will say, check to see if these are inverses, okay? And then you'll stick one inside of the other and vice versa, and you'll see if it reduces to x. And if it does, then they are inverses, okay? They undo one another, all right? So definition of an inverse, they are inverses of each other if you can plug one inside of the other and do it the other way as well, and it reduces to be x each time, okay? That's kind of the definition of an inverse. So like this and like this, all right? Which of the functions are inverses of each other? Or are the inverse of, of this guy? They're giving us two options. They're saying, is this the inverse of that, or is this the inverse of that? Okay, so we're going to check to see. And how much room do I have? I'm going to go, let's go down over here to do g of x, okay? So, all right, so here we're going to do f composed of g of x, and then we're going to do g composed of f of x, okay? All right, f composed of g of x means we're shoving g into there for x, which is really gross. All right, so starting with f of x, we have 5 over x minus 2, okay? And in its place, we're going to put the g part, which is x minus 2 over 5. And we're going to do that, okay? Now this thing, this is kind of gross. We're going to have to, in order to add this to this, we're going to have to find a common denominator. So I'm going to change this 2 to be 10 over 5. And so we have x minus 2 minus 10 over 5, which will be x minus 12 over 5 on the bottom, and then 5 on the top. Okay, so we have a fraction on the bottom, and we're going to keep flip him to the top. So this will be 5 times 5 over x minus 12. And this is like 5 over 1, so this would be like something like 25 over x minus 12. We don't really care what it is because it doesn't come out to be equal to x. It does not. Okay, so I don't even have to do this side because if it already doesn't come out as x, I know that this is not the inverse. So I'm going to cancel him off, and he's not even going to be an option, okay? Then let's try h. Okay, so over here, let's do f composed of h of x to test him, and let's do h composed of f of x to test him, and let's see what he looks like. Okay, so starting with f composed of h, we're going to take h and we're going to plug it into f, so he looks like this. So 5 over x minus 2, and in its place we're going to do 5 over x plus 2, like that. Okay, and from here, when we simplify, we got the plus 2 minus 2, those will cancel off. So we have 5 over x, which we can keep flip to the top. And this is 5 times x over 5, which is really like 5 over 1. And those guys cancel, and we end up getting x, and that checks out. Okay, let's make sure the other side checks out also. So let's put in here, oh heavens. Okay, all right, okay. So we're starting with the h now. So we have 5 over x plus 2. And x is 5 over x minus 2. Okay, all right, so we're just going to let this 2 chill for a second, and we're going to keep flip this guy to the top. So we have 5 times x minus 2 over 5. which is really like 5 over 1. Okay, and I'm going to cancel those 5s. So I have x minus 2 here, but now we're going to let that 2 come back. And plus 2 minus 2 are going to cancel, so that equals x. So we can see from composition that h of x is the inverse of this guy. Okay, by plugging one into the other and vice versa, we can see that those two are inverses of each other. G of x is not. Okay, all right, so this is just kind of illustrating what I've already said before. The graph of f of x, the graph of the inverse is a reflection of the graph of f across the line y equals x, and that's why these guys come out to be y equals x when you compose them. Okay, so you have a line here, you have a line here, those are reflected across that dotted line. Okay, so you can kind of see how that works. Okay, going to the back. One-to-one functions. Okay, all right. We've done stuff before that's called the vertical line test, okay? So here's the deal. I'm going to start with a function, and we're going to use the, let's use the y equals x squared function, a parabola, a quadratic function, y equals x squared, okay? To determine whether he is a function. Is he a function? We would do the vertical line test. And the vertical line test says, if I draw vertical lines, he passes, right? He's not only touching at one place across those vertical lines. So the vertical line test will say, yes, he is a function. Okay? Now, if I'm trying to say, okay, here's my next question. Is his inverse a function? Okay, now what I can do is I can actually graph the inverse and then do the vertical line test on that, or I can keep with my original function and do the horizontal line test. And when I do the horizontal line test, I notice that it's hitting at multiple places along this graph. So the horizontal line test says, no, his inverse is not a function. Okay, I hope that kind of made sense. So you're doing the vertical line test to see if the original function is a function or not. You do the horizontal line test to see whether his inverse is a function or not. Okay, so let's read that box. A function f has an inverse function if and only if no horizontal line test intersects the graph at more than one point. Okay, now the way that they word this is saying that a function has an inverse function. Now, even though it doesn't pass the horizontal line test, it will still have an inverse relation. Like the inverse relation of y equals x squared, like we talked about above, was x equals y squared. And x equals y squared is an inverse relation to y equals x squared, but it is not a function himself, right? Okay, so that's kind of how that wording happens, all right? Let's go to, I'm going to skip the definition of one-to-one. I don't like the definition of one-to-one. Let's go down to example. Use the horizontal line test to determine whether each function has a inverse function or not, okay? Now, just because it doesn't have an inverse function doesn't mean it won't have an inverse relation, but it won't be a function, all right? So part A is x cubed minus 1, and what I'm going to do is I'm just going to think about this parent function and what it looks like, okay? So x to the third power minus 1 is just a cubic function, but it's down at 1, so he's going to look like this, right? He's going to look like this, something of that nature. That's x to the third power, okay? And we're doing the horizontal line test to see if he has an inverse function. So horizontal line test, I go across, and I say, yep, it looks like he passes, so yes, he has an inverse function, okay? Not just an inverse relation, his inverse is in fact a function, okay? All right, part B, x squared equals 1, or excuse me, x squared minus 1, we already kind of did this one actually, is x squared is a parabola, but it's down at 1, so he looks like this, okay? And he is a function, but his inverse, if we do the horizontal line test, is not a function. So no, he, I'm going to say his inverse is not a function. His inverse is not a function, all right? He has an inverse relation, but he does not have an inverse function, okay? All right, guidelines for finding an inverse function. They give 5 steps for some, I know why they give 5 steps. So these steps 1 through 4, are kind of a consolidation of the steps 1 through 4 that I did up here. Except the only difference is I think they combine some of these steps, but they do add in there a horizontal line test to decide whether it even has an inverse function or not. So they do the horizontal line test to start with, and then step number 5 is using composition to plug one inside of the other one to see whether it you did it correctly. And when you compose them, they have to end up boiling down to x. Okay, so find the inverse of this guy, and 5 minus 3x over 2. Really, this guy can be rewritten as 5 over 2 minus 3 over 2x, which is a linear function. Okay, so if we think about a linear function, he is going to pass the horizontal line test, so his inverse will have a function. So he has an inverse function. Okay, and we're going to find that inverse function here. So step number 1, or number 1, we're going to be doing the 4 steps to him, like I did on the front page. So y equals 5 minus 3x over 2, and I'm going to cheat. I'm going to go and rename them x and y. So switch the x and the y, so we're going to do that. Okay, all right. Now we are solving for y. We're trying to get this y by itself. So let's multiply the 2 over to start with. So 2x equals 5 minus 3y. I'm going to subtract the 5. So 2x minus 5 equals negative 3y. Divide by negative 3. And we have that f inverse of x is equal to 2x minus 5 over negative 3. Okay, now I'm going to save some time because we've already done composition of one function, and really to check to see if our answer is correct, we would need to stick one inside of the other and make sure it boils down to x, but I'm going to save some time and skip that step. Okay, let's go straight to number 2. Number 2 is a cubic root function. Okay, so if we think about what a cubic root function looks like, it is one of these, okay? And if we do the horizontal line test, okay, he is going to pass the horizontal line test. Even though he kind of levels out here, he is still going up, so he is going to pass the horizontal line test. He is going to have an inverse function, and we're going to find that guy. So this is number 2. This is this function here, and we're going to y equals the cubic root of x plus 1, and I'm going to cheat and switch my x's and y's just right over top of them. And now we're having to solve for y. So the first thing that we want to do is cube both sides. And x to the 3rd power equals y plus 1. So x to the 3rd power minus 1, if I subtract that 1 over, equals y. And last step is that f inverse of x is equal to x to the 3rd minus 1. Oh shoot, is it called f inverse? Yeah, they're both f inverses. Sometimes they'll try to trick you and call this h of x, so he will be h inverse instead, whatever, okay? And what we're doing by finding inverses, I want to kind of reiterate this again, is that if this guy is the inverse of this one, then these two undo one another, okay? So they unravel each other, okay? So that's kind of the rule on inverses, and that's all I have for that section.